Okay, so that's how you do those. Let's go ahead and do another one. We'll just say, let's see. Let's just do one that is a 18 kilowatt range, right? Big range. So I got 18 kilowatts. How many kilowatts is that over 12 kilowatts? 6. For each one of those, we're going to increase, each one of those 6, we're going to increase by 5%, right? So I'm going to need both hands for this. 5, 10, 15, 20, 25, 30, right? I need to increase that by 30%. I can do 6 times 5 is 30, right? So I'm going to do a 30% increase to my column C value. So my column C value, if you look on the table for a single appliance, is 8,000, right? And I'm going to do plus 30% on my calculator, right? And so if I do that, I'm going to add another 2,400. So 8,000 plus 2,400, that should be 10,400. So they're fairly straightforward. It just gets a little confusing when you get into that. Just remember, for every one of those, right, I need to increase it by 5%. If you got to count it out on your fingers, that's okay. 5, 10, 15, 20, 25, 30, right? If that's how you get there, that's fine. As long as we all get to the same answer, we're okay. If you can make this process in your mind, 6 times 5%, right? If I do 6 times 5% on my calculator, it's not going to spit out to 30%, okay? So that's where that becomes a disconnect. But if you just need to go 5, 10, 15, 20, 25, 30, right? That gives me my 6. That's fine too. Whatever gets you the right answer, that's what we want to do, right? All right, air conditioning, heating, and air handler. So remember, if that air conditioning motor is the largest motor that they give you, we're going to have to do that at 125%. And I can tell you, in most of the calculations that I've ever seen on the exams, that's the only motor they give you, so that's going to be the largest one, right? And we're going to compare that to 100% of the heat, okay? And so we're going to pick the largest of those two loads because they're non-coincident loads. They're not loads that are going to be there at the same time as the other, all right? So what's our service demand load for a dwelling unit with an air conditioner rated at 30 amps, 240 volts, versus an electric heating at 9.6 kilowatts with an air handling unit rated at 4 amps, 240 volts. So we got kind of a combination unit here. It says the air conditioner motor compressor is the largest motor type of the load in the dwelling unit. And so what we're going to do is we're going to take a look at the condenser here, the motor condenser on there. We're going to do that at 125%. Now both of these, the heating and the air conditioning, are both going to have 4 amps worth of fan on them, okay? So we're not going to mess with that at all. We'll just omit that whole thing from the equation here, all right? So our heating's going to be at 9,600, right? And how did we get that? Well, it said 9,600 right in the question. And then we take a look at our 30 amps, 240 volts. 30 times 240 is going to give me 7,200. But that 7,200, since it's the largest motor, we're going to do it 125%. So we're going to take our 9,000 volt amps and compare that to our 9,600. Which one's bigger? The 9,600. We're going to use the heat. Okay? Let's take a look at another one. What's our service demand load for a dwelling unit with an air conditioner motor compressor rated at 20 amps, 240 volts, versus electric heating at 7,500 watts at 240 volts? The 20 amp air conditioner motor compressor isn't the largest motor type load in the dwelling unit. So that means each of those will do at 100%, okay? So what I've got is my heat at 7,500. And then I've got my 20 amps, 240 volts, that's 4,800. Now obviously my heating is going to be larger than my air conditioning in this circumstance, so we'll use the heating. And we'll omit the air conditioning out of the calculation. And again, we can do that because we're never going to run those two at the same time. So if you give me the larger of the two, we should be okay. All right, let's go ahead and take a look at a total unit dwelling calculation here. So I've got, we're going to use this doing the standard method, and I got a 1,500 square foot dwelling unit that contains a dishwasher, a disposal, a water heater, a dryer, a range, AC, and heat. All right, I guess let's go ahead and do this up on the board. And we'll take a look at this kind of step by step and see what are my criteria here. First off, I've got 1,500 square feet, right? And we're going to do that times 3 volt amps per square foot. Okay, so that's going to give me 4,500, right? And then I also need to remember I need my 2 small appliances. So I got my 2 small appliances. Those are 1,500 a piece, right? So a total of 3,000. And then I've got my laundry load, right? And that is going to be 1,500. So what I've got here is a total of 9,000. Total of 9,000. The total of which, I'm trying to figure out so I don't write, down lower. I don't want to write basically in the area where that slide is, okay? So I got 9,000 here, and I'm going to take my first 3,000 at 100%. And that's 3,000, right? And then I'm going to take my balance. 9,000 minus 3,000 is 6,000 at 35%. 6,000 times 35%, I believe, is 2,100. Let me confirm that on the calculator. This is one thing that we definitely don't want to do, is do stuff in our head. Use a calculator. So I got 6,000 times 0.35 or 35%, 2,100. And so we add those two numbers together, and we end up with 5,100. And so this is really step one, right? And so step one, I'm just going to move that over here. I'm going to call that the light. Okay? It's the general lighting and receptacle load, but we're just going to call it the light. Okay? And we calculated that at 5,100. Now we take a look at the equipment that we have. We've got a dishwasher, a disposal, and a water heater, and a dryer. So other than dryers and air conditioning and heating equipment and cooking equipment, how many appliances do I have? I've got 3 of them. I've got a dishwasher, a disposal, and a water heater, right? So 3 of them are going to be done at 100%. So our dishwasher is rated at 1,500. Our disposal is rated at 1,000. And our water heater is rated at 4,500. Because I only have 3 appliances, right? I've only got 3 appliances. I'm going to do those at 100%. So step 2, adding that stuff, okay, at 100%. We're just going to leave them alone. And then we take a look at our dryer. We got a dryer, right? We'll call that step 3. Remember, that's a 4 kilowatt dryer. But remember also that the minimum is what? 5,000, right? So we're going to add that in at 5,000. Okay, and then what do we have left? We've got a range. And that's 14 kilowatts. Okay, that doesn't fall into column C, that falls into column C plus, right? So what we're going to have to do is we're going to have to figure out how many kilowatts we have over 12 kilowatts. That's 2. 2 times 5 is a 10% increase. So we're going to take our 8,000 in column C plus 10%, and that's going to give us 8,800, right? And so we'll use the value of 8,800 right here. And then what's left? We've got our air conditioning and we've got our heat, okay? So it doesn't tell us anything about the fan, just says 17 amps, 240 volts for my air conditioning, right? So we're going to do air conditioning versus heat. So our AC is going to be 17 times 240, that's 4080, and then I don't see any other motors, right? So we got to assume that's the largest motor in there, so we're going to have to do a 25% increase to that. Okay, so 4080, let me just double check my math on that. 17 times 240 is 4080, and then we're going to do that at 125%, and so that's going to be 5,100 on the AC. And then the heat is 8,000. Hey, which one's bigger between these two? The AC or the heat? Now the heat, right? So we get rid of that. And then really the last step is just to add all those values together. All right? So we take our 5,100 plus 1,500 plus 1,000 plus 4,500 plus our 5,000 plus 8,800 plus 8,000. I get 33,900. That should be our total calculated demand load on there. Let's see how we did. So our general lighting, 1,500 times, I messed something up along the way. I probably added wrong. Let's see what we did here. It's okay to make mistakes here, okay? Even I make mistakes. You can see that right now. So let's see, we've got our general lighting is 1,500 times 3, plus our small appliance, plus our laundry load. That's a total of 9,000. Our first 3,000 is going to be at 100%. The balance at 35%. That's 5,100. Let's see. Did we get that right? Yep, we got that right. The light's at 5,100. All right, let's see where we messed up on this. I say we, it's me. All right. So we got the 5,100. We did our dishwasher at 1,500. Our disposal at 1,000. And then our water heater at 4,500. Those are all at full nameplate value. So that's going to be a total of 7,000, right? Our clothes dryer we did at 5,000. And then our cooking equipment, let's see, that range is at 8,000 right there. I've actually got a bad graphic here. So I am correct up on my board. This is the correct calculation. What we've got here up on the board is correct, the 33,900, not what we have on the graphic. The graphic is wrong on the thing because the graphic didn't take into account that that's a 14 kilowatt range, right? It's only doing a 12 kilowatt range, and so we're going to have to add 800 to whatever the graphic says. The graphic says 33,100. 33,100 plus 800 is going to give us our same 33,900. All right? And so our clothes dryer was at 5,000. We did 8,800 for our range. Our air conditioning was 17 amps, 240 volts. That is going to be 5,100 times 125% because it's the largest motor, right? And then our electric heating we're going to do at 100%. And so that's 8,000. So our 8,000 is bigger than our 5,100, so we move over our 8,000. Then we add all those things together and we'll end up with 33,900. 33,900 like we see up here on the board, okay? That's the correct calculation, not what I have on the graphic, all right? Sometimes we have the graphic screwed up. That's all right. We'll get that corrected, but that helped us out to double check and make sure that we had everything just right, okay? So it's okay to make mistakes as we're going along. I made a mistake when I made the graphic. But when we double checked our math up here, the stuff that we did up on the board was correct. All right. Now, let's let you guys do one here. It says, using the standard method, what's the total volt amp demand for a 2,200 square foot single family dwelling with single phase 120/240 volt service and the following equipment? A 14 kilowatt range, a 5,500 watt clothes dryer, a 4,500 watt water heater, a 1,500 watt dishwasher, a 9.8 amp garbage disposal operating at 128 volts, and then 240 volt 24 amp air conditioner, and a 20 amp 240 volt electric heater. And again, it looks like that air conditioner is going to be our largest motor, so we'll have to do that at 125%. You guys go ahead and work that out. I'll give you a couple of minutes to do that. Pause the button there until you've got it worked out, and then you can check it against what we have here. All right, let's take a look at the solution here. All right, so using the standard method, what's the total volt amp demand for a 2,200 square foot single family dwelling with single phase 120/240 volt service and the following equipment? The 14 kilowatt range, a 5,500 watt clothes dryer, a 4,500 watt water heater, a 1,500 watt dishwasher, a 9.8 amp garbage disposal operating 120 volts, and 240 volt 24 amp air conditioner. And then a 20 amp 240 volt electric heater. By the way, it's got 17,000 BTUs. I don't care what the BTUs are, I just made that up. Okay, so if you're trying to figure that into your calculation, it's just there to distract you. You don't necessarily have to use every single piece of information that they give you. So let's take a look at the calculation here. We got 2,200 square feet times 3. That's going to be 6,600. And then we've got our two small appliances at 1,500 apiece. That's going to be 3,000, plus our laundry at 1,500. So we add all those together, the 6,600 plus our 3,000 plus our 1,500, that's 11,100. And then we go down there and we take the first 3,000 at 100%, that's 3,000. And then we take the balance, 11,100 minus 8,100, at 35%, or minus 3,000 gives us 8,100 at 35%. So we do the math on that, and that gives us 2835. We add that back to the original 3,000, and we get 5835. Down below there, we've got our fixed appliances, okay? We've got our dishwasher, our disposal, and water heater. How many do we have? We've got 3 of them, right? So we're going to do those at 100%. So my dishwasher is 1,500. My garbage disposal is 1176. How did I get that? I took my 9.8 amps times 120 volts, and I got 1176. That's how we got that. That's volt amps, right? And then my water heater, the nameplate was 4,500 watts. So those 3 added together is 7176. And then we take a look at our clothes dryer based off of 220.54. And that is 5,500 watts. Well, 5,500 is larger than 5,000, so we'll use the nameplate value in this case, 5,500 watts. And then we take a look at our cooking equipment, and again, I've got that same 14 kilowatt range, except this time I got the math right. I got my 14,000, which is going to be 2,000 over, for every kilowatt that I have over 12,000, we're going to increase by 5%. 2 times 5 is 10%. And so I take my 8,000, my column C value, and I add 10% to that. That gives me 8,800. And so we add that into the equation, the 8,800. Then we take a look at our heating and cooling. Now our air conditioner, that's 24 amps, 240 volts. That's 5,760 volt amps. We're going to have to do that at 125%. So that's going to be 7,200. And then my electric heating is 20 amps, 240 volts. So that is going to be 4,800. 20 times 240 is 4,800. We're going to do that at 100%. So 7,200 is larger than 4,800. So we use our 7,200. And then we just add our values together. Remember, we don't have any miscellaneous loads or additional motors. So we take our 5835 plus our 7176 plus our 5500 plus 8800 plus 7200, and that gives us a total of 34,511. 34,511. Now, I want to show you something real quick while we're here. So if that's at my 34,511, I believe was that number. So 34,511. If I want to size my service, what I'm going to do is I'm going to divide that by my source voltage. In this case, my source voltage was 240 volts, right? So 240. So I'm going to take my 34,511 divided by 240, and that's going to give me 143.79 amps. So if this is volt amps, right, and this is volts, volt amps divided by volts will give me my amps. All right? So what size service do I need for that? Well, next size up from that. Where am I going to find that? Jump into your code book here. Okay? We're going to jump into our code book, and we're going to go to 240.6. 240.6. So 240.6, that's going to be on page 100. That's easy and convenient. Page 100. And bottom of the left-hand column, these are our standard size overcurrent devices. So we calculated we needed 143, right? Okay, so we needed 143, and we're going to go to the next size up from that, which is going to be 150 amp service. So that's how you would do that. That's just kind of taking that one extra step. And I'll show you how we'll actually size the conductors that go to that when we get into Article 310. But for now, that's exactly how you do the standard method on a single-family dwelling unit. Let's go ahead and take a look at doing multifamily stuff.